In this next section, we'll look at what's called set association, and ultimately this is the interactions between sets, or the interactions of a set. So the first thing that we'll look at, and we're going to look at most of these graphically, but the first thing we'll look at is what's called the union of two sets. And the union of two sets is written as X union Y, and this is equal to all of the elements of X plus all of the elements of Y. So we're saying if it is either in the set X or in the set Y, then it is going to be part of this X union Y. So if we have an X that is equal to A and B, and a Y that is equal to B and C, then we can say that X unioned with Y is equal to A, B, and C. And again, you'll notice that B is not in here twice. That's because a set can only represent each element once. Now, if we were to do this graphically, let's say that this green set over here on the left is our set X, and that the blue set is the set Y, then the area that we're looking at, or the graphical representation of this, is anything that is encompassed by X or Y. And so looking at that from a shading perspective, that is all of this area that is shaded in here. So literally everything that is part of X or is part of Y. Now, if we look at the intersection of two sets, this is written X intersect Y, is anything that is part of the set X and is also part of the set Y. So if we look at that same, X is equal to A and B, and Y is equal to B and C, then X intersect Y would be equal to just the element B, because it is the only element that is in both X and Y. And again, if we look at this graphically, we'll assume we have X and Y as our two graphical set elements. The area that is X intersect Y is this area here in the middle that is part of both X and Y. If we look at the difference of two sets, this is just written X minus Y, then we're looking at things where the element is a part of X but is not part of Y. So this is everything that is X and is not included in Y. So again, if we look back at our previous example and we say that we have an X that is equal to A and B, a Y that is equal to B and C, then X minus Y is going to be equal to just A. And again, this is all of the things that are in X that are not in Y, because B is in both X and Y. We subtract the B out of X. And again, drawing this graphically, if we have our X and our Y, we're looking at everything that is X and is not part of Y. So we would not be including this area here in the middle that is part of Y that we are subtracting from X. Now, the next thing that we'll look at is a disjoint set, and that is where X intersect Y is equal to the empty set. In other words, this is saying that the two sets, X and Y, have nothing in common. And you can see that graphically over here, where there is no area of overlap between X and Y. An example of that from mathematics would be if X is equal to A and B, and Y is equal to C and D. In this case, there is nothing that is shared between X and Y, so we would say that the sets X and Y are disjoint. Next thing we'll look at is the complement of a set. And written mathematically, this is saying that we have an A intersected with the complement, as you can see here, A prime, is equal to the empty set. Basically, the complement is everything in your world, everything in the omega that we looked at from last week that is not part of A. Now, a couple things on notation. This A prime you'll see me use a lot throughout the course, but there's a couple different representations in different textbooks, and we'll see a couple of these from some of our guest lectures over the semester. But for now, we'll say that A prime is equal to AC, just a superscript C there for A complement, and that is also equal to A with a bar over the top of it. And some of those you guys may have seen before, but they ultimately all mean the same thing. They just mean the complement of the set A. Now, one of the important things here is that this is A intersect with its complement is equal to the empty set. But it's important to recognize that you have to define your world first. And this is kind of that throwback to the opening message where I mentioned that the world will make more sense. If we look at our world, this is our omega. And for those that are more familiar with some of the discrete mathematics, you may have seen this written as a U, where U is your universe. The U and omega are ultimately the same thing. In probability, we tend to use the capital omega for most of our world or universe representations. Now, again, looking at this, if we say that this green circle A is our area of interest, then the complement of A is everything inside our universe, everything inside this blue rectangle that is not part of A. And so you can see that here represented by the shaded in area. And so that area then would be A complement. And again, that can also be written A with a superscript C or A with a bar over the top of it to represent the complement.